Math for manufacturing. Just like machinery and equipment, math is a valuable tool used by all manufacturing companies. It has to be used properly, but it doesn't have to be difficult or intimidating. Most of the math we use on the job builds on simple ideas: counting, measuring, multiplying, and dividing. In this unit, we'll start at the very beginning. We'll take it one step at a time. By the end, you should feel more comfortable with the numbers you see every day, and hopefully you'll be better prepared for new ideas you'll meet as we go forward. In this video, we'll use a concept known as the number line to illustrate a few basic math principles. We'll try to avoid getting too bogged down in the details here. We just want to hit the high points. We can go into more detail on each of these concepts later on. Counting in units. Counting is the first kind of math any of us learned. 1, 2, 3, 4. But in manufacturing, counting has a purpose. We count parts coming off a machine. We count pieces going into a box. We count how many parts we've made and how many we still have left to go. But before we count too far, let's stop and have a look at a special number, the number 1. What does it mean to have one of a thing? If we have one, then we have all of a thing. We have what is called a unit of something. Now, this could be a metal pin like the ones we're making in this factory. Here's 1 pin, 2 pins, 3 pins, but we could also be counting packages like these. 1 package, 2 packages, 3 packages. We could be counting cases of pins or even truckloads. In manufacturing, if we're doing math, even math as simple as counting, we need to know what the unit of measure is. 1 pin is a single piece. 1 package might hold many pins. A case might hold many packages. 1 truckload might contain hundreds or even thousands of cases. These are all 1, but they're not the same amount. A number doesn't become useful unless we know what it belongs to. If someone says, "We shipped 30 yesterday," the real question is, 30 what? 30 pins? 30 boxes? 30 pallets? Units matter in length measurement too. 1 inch is not the same as 1 millimeter. 1 foot is different from a meter. A number without a unit can cause serious mistakes. Keeping track of units is an important way to avoid problems on the shop floor. The number line. Before we move on, let's take a quick look at something called the number line. The number line is just a straight line with marks that show where the numbers appear in sequence, one after the other. If we put a mark for 0 here, and then a mark for 1 pin here, and then another for 2 pins, then 3 pins, 4, 5, we can see how the numbers start to add up. Each step to the right means we have 1 more pin. If we step to the left, it means we have 1 less. Now, we could use the number line to talk about all kinds of things like packages, cases, and truckloads, but for now, we'll use it to discuss our product, these simple metal pins. As we go through this badge, we'll come back to the number line to help explain other ideas, but for now, it gives us a clear way to see our numbers on a single straight line. Addition and subtraction. Once we understand what we're counting or measuring, we can begin looking more closely at addition and subtraction. Now let's look at these pins. If I have 5 pins and I add 3 more, I now have 8. It's a good idea to practice adding in your head, but you can do addition on a calculator. First, be sure your calculator reads 0. If it doesn't, press the clear button. Now, press 5, then the plus button, and then type 3. When you press the equals key, you'll see the calculator gives 8 as the answer. We can see addition on the number line too. Here we have 5 pins. If we add 3, we see that we have counted up to the 8 mark. Subtraction is similar. If I start with 10 pins and take away 2, I end up with 8. On your calculator, type 10, the number you're starting with, then the minus sign, then 2, the number you're taking away. and then hit the equals key. You see the calculator gives 8 as the correct answer. That's all addition and subtraction really are, keeping track of what we have, then what we add, and what we take away. On a production line, we do this every day, sometimes without even thinking about it. We count incoming materials, finished parts, pieces that still need work. The math is simple, but the skill is important. So be sure to practice until you're confident that your answers are correct. Fractions and decimals. We already looked at how important the number 1 is, but sometimes we work with less than one whole unit. People don't usually eat a whole pizza or a whole pie. We often split things up into pieces that are less than 1. One way to talk about numbers that are less than 1 is by using fractions. Fractions are a way to express parts of a whole. They look like this: one number over another number. The number on top represents the part that we have, and the number below tells us how many parts make up the whole. If we cut a pizza right down the middle into 2 pieces, we say we have cut it in half. We actually have 2 halves. If we look at both pieces together, it's 1 pizza, but we could still write that as a fraction, 2 over 2. The 2 on top says we have 2 pieces, the part, and the 2 below says that 2 pieces make up the whole. If someone eats one of the halves, we only have 1 half left. We could write that as a fraction. It would be 1 over 2. 1 is the part that we have left, and 2 would be the number of parts that would have made the pizza whole. We'll look more at fractions later, but for now, let's look at the halves on the number line. Here's 1 half. Then 2 halves is a whole. Then we have 1 1/2, 2, 2 1/2, and so on. Another way to talk about numbers that are less than 1 is to use decimals. Decimals start by dividing a unit into 10 parts. We can then label them 0.1, 0.2, 0.3, and so on. When we get to the halfway point, you'll notice that the decimal version of 1 half is 0.5. This may be familiar to you, but if not, don't worry. We'll learn more about fractions and decimals in later lessons. Fractions are commonly used in construction, but decimals are a little more common in manufacturing. You'll probably prefer using decimals. They're handy because they're easier to use with a calculator. Multiplication and division. Not everything we do happens one piece at a time. In manufacturing, we often work in groups: packages, cases, batches, and orders. Multiplication is simply a faster way of adding the same group again and again. If one package holds 10 pens and we need 5 packages, multiplication helps us find the total number of pens. You may be able to count by 2s, or by 5s, or by 10s. When you do this, you're actually multiplying. Let's look at these pens and I'll show you what I mean. If we have 3 sets of 2 pens, we have 6 pens. Notice we could count by 2s. 2, 4, 6. 2 times 3 equals 6. We could do the same thing with sets of 3. 3, 6, 9, 12. 3 times 4 equals 12. I like to think of multiplication as laying out groups in a grid like this. We can do multiplication on our calculator just like we did for addition. Let's enter 3 times 4. First, clear the calculator. Now press 3, then the multiply key, then press 4 and the equals key. Just like we saw, 3 times 4 equals 12. Division is the opposite of multiplication. If we have a group of 16 pens and divide by 2, we'll be left with a group of 8 pens. Since 8 times 2 equals 16, then 16 divided by 2 equals 8. The order is very important when we do division on a calculator. The number we're dividing or splitting up comes first. Then we enter the number of groups we're splitting the first number up into. Let's do some division on a calculator. Let's divide 6 by 3. Enter the number 6, the number we're splitting up. Then enter the division key. Then enter 3. The equals key tells us it's 6 divided by 3 equals 2. Now, this takes some practice, so be patient. Negative numbers. We've seen that if we go to the right on the number line, the numbers get bigger and bigger. In fact, there's no limit to how far we can go to the right. But if we go to the left, we soon hit 0. It turns out there's really no reason to stop there. We can have numbers that are less than 0. You might think about a building that has a basement. You can go below ground level. We call these numbers that are less than 0 negative numbers, and we put a minus sign in front of them. This machine uses negative numbers. We've made this point on the machine 0. If we move the tool up, the numbers get bigger. If we move the tool down and go past the 0 or origin point, the numbers keep counting up, but we say that they're negative because they have moved below 0. Negative numbers aren't really mysterious, they're just a way to show that our numbers are less than 0. Understanding this helps us read digital displays, dial indicators, and machine movements with confidence. Conclusion. Math doesn't come easy to a lot of people, but it will help if you do as much practice as you can. Math skills are in demand in a lot of businesses and trades, and the better you get at math, the more things you'll be able to do. As we continue through the Math for Manufacturing badge sequence, we'll take each idea step by step, connect it to real tasks in a shop, and show how these basic concepts make the work easier, safer, and more accurate. All math begins with the number line. Once that's clear, everything else becomes much easier to understand and to use on the job. By participating in this badge series, you're taking an important step in developing your own understanding in a very useful way. Math skills pay off in a lot of ways, so keep practicing until you feel comfortable with these concepts. Then continue through the series and complete all the badges, and let us know if you have any questions or problems.